Another principle of the modern SDR tools is the exact frequency tuning with compensation for PLL and DDS style rounding errors. There are several sources of errors coming into our software, including double type rounding errors. I hope nobody is using single precision floating point numbers, as well as DDS PLL setup quantization because of the short coefficients, and of course programming errors. Let's see an example. Let's tune to one of the receivers, web receivers, to receive the lower beacon of the Q100 receiver. This is the tuning frequency. Copy, and another SDR. Let's paste it, and now we have two web SDRs tuned to the same frequency. And then we started WSJT-X software, and we are able to monitor both web SDR receivers at the same time in parallel. And what we see is that the frequencies are like about 50 Hz apart. Although both receivers are using GPS clock synchronization, they are using different hardware. If we look at the diagram of both web SDR receivers, we can see that the first one is using Airspy as a receiving hardware, and the second one is using RTL-SDR as a hardware. So the problem of different receiving frequencies may be in the hardware. So the hardware is setting the receive frequency or reports it incorrectly. Moreover, both web SDRs are using some marginal GPS receivers, so the frequency is jumping up and down. It's not synchronized nicely. Let's get back to our Pluto SDR scanner, and let's receive a frequency of 760 MHz exactly, with the maximum zoom factor. I know that the carrier should be exactly at the frequency 760 MHz exactly, but it's about, let's see how much it is off, about 0.4 Hz off. Why should we see the frequency exactly at 760 MHz? We should see the signal exactly on the frequency because it's a 19th harmonic of the clock generator connected to the Pluto SDR. So it should be exactly here. And according to my calculations, the error caused by rounding the double floating point values should be less than 0.01 Hz, and here it's a few times more, definitely. So I think that the frequency is caused by the problems and the roundings in the PLL DDS programming. And actually we see this offset because I edited the config file of the Pluto SDR scanner, and I disabled the frequency compensation. Let's turn on the compensation formula. Now I turned on the frequency error correction variable in the config file, and now we see the carrier exactly where it should be. The program now compensates for the possible DDS PLL programming error, and I measured at different frequencies and at different spans. The offset is about 0.01 Hertz. It's a 5-minute test, so it's like very close to the limit caused by the double floating point arithmetics. And now I'm satisfied, so it's like about 30-40 times less than it was before. I believe everybody can compensate these problems by carefully calculating the frequency in their software.